So this is just going to be an introduction to equations. This is not going to be solving multi-step equations or anything yet, okay? So the first thing that I want to talk about when it comes to equations is that an equation is a mathematical sentence using an equal sign. So an equation has to have an equal sign. That's the difference in everything that we've done thus far, which have been expressions. Expressions do not have equal sign. So we can say equations are either true, false, or open. And I'm going to give you examples of each type. Okay? So again, equations can be true, false, or open. And on your assignment today, you're going to have to identify them as being true, false, or open. So make sure you're really paying attention to what they are. All right, so let's first talk about true. True equations have both sides equal. Same thing. An example of a true equation is 24 plus 18 equals 20 plus 22. Both sides equal what? Both sides equal 42. Yes, you may turn off the lights. So again, both sides equal 42. So notice that there are no variables in this, are there? No variables. So an equation does not have to have a variable. An equation just needs to have an equal sign. And it has one. Now, for an equation to be considered false, sides are not equal. I mean, true and false are opposites of each other, right? Again, false, the sides are not equal. For instance, if we had 7 times 8 equals 2 times 27. Seven times 8 is what? 56. 2 times 27 is 54. They're not equal. It is false. It is a false equation. So true equations, false equations. Notice that this false equation doesn't have any variables either. Option. Our last option are the trues, or excuse me, the opens. The open equations. So in an open equation, it may or may not be true or false. It's going to depend on what number you put in place for the variable. So again, an open equation may or may not be true or false. May or may not be true or false. It depends on the number used for the variable. May or may not be true or false. Depends on the number used for the variable. For instance, 2x equals 8 is open. Because depending on what number we put in for x, it may or may not equal 8. If we put a 7 in here, 2 times 7 is 14, so that would be false. However, if we put a 4 in there, 2 times 4 is 8, then it's true. So it's open because it has a variable. And it depends on what we put in for the variable. We could make it true or we could make it false. The answer to this, if I said what type of equation is this, open, false, or true, this would be open because it has a variable. Anything that has a variable is open. Anything that has a variable is open. Let's add that in there. Anything with a variable is open. Anything with a variable is open. So now what we're going to do is we are going to look at an equation. I'm going to tell you what I want you to use for the variable, and then we're going to decide if we use that number for the variable, if it's going to make it true or false. Okay? So let's write an equation. We're going to write the equation 32 equals 2x plus 12. And I'm going to say that x equals 6. I want to know if we put in a 6 for the x, would this be true or would this be false? So a lot of you are just doing it in your head, right? I know how you are. This would be 2 times 6 plus 12, which would be 12 plus 12, which is 24. And 32 is not equal to 24, so now this is a false equation. 6 is not a solution of this equation. 6 is not a solution of that equation. What if we had the equation 6m minus 8 equals negative 5, and I said that m is 1/2. 6m minus 8 equals negative 5, and I'm saying that m is 1/2. Sam. So 6 times 1/2 is 3. Half of 6 is 3. And 3 minus 8 is negative 5. So the sides are the same. So yes, this is true. Now I want you to be aware of when they write these on your assignment. I think the way they have it looks a little confusing. They're going to write your equation. Like let's say they have... Then they're going to use a semicolon, and they're going to put... That means, make sure you listen to me, this part here is your equation. The 6 is what you're substituting in for the variable. So I really don't like the way they have it written on your assignment, but I want you to understand what they mean by that. They're wanting you to put the 6 in for your variable. So I'm going to rewrite this as, instead of 5 times m, 5 times 6 minus 6 equals 40. And 5 times 6 is 30. 24 equals 40. False. Do we feel okay about saying if something is true or false? Wonderful. Easy. Easy peasy. Good. Easy, easy, easy. What if you had to write the equation? We're going to write the equation. And I use the words, the sum of 4x and negative 8 is 8. I gave you that word sentence, and I said I wanted you to write the equation. What are some key words here that help us know what to write? Some key words. I haven't asked calling you. Sum is addition. So adding 4x and negative 8. What's another word that's a clue? 4. Well, yeah, the 4x for sure we want to use. We want to use the negative 8. We want to use the 8. There's another word up here. Dawson? Not always. Is equals. Is means equals. Is means equals. Is means equals. Sum of 4x and negative 8. So we would show that 4x plus negative 8. The sum of 4x and negative 8 equals is 8. This is not going to ask you today to solve. Again, this is today not going to ask you to solve. It just wants you to write the equation. Okay? What if I said, do another one here, and you can choose whether you want to write the words down or not in your notes. The product of 9 and the sum of 6 and x is 1. The product of 9 and the sum of 6 and x is 1. So I kind of liked how before you guys identified your parts, your numbers, and your variables. The 6, or the 9, the 6, the x, and the 1. We need all those things in here. Product means multiplying. Sum means adding. Again, is means. Alright. What are we going to do with the product of 9 and the sum of 6 and x? How are we going to write that? What is that going to look like, though? What do I need there? Parentheses. This is going to look like distributive property. 9 times the sum of 6 and x equals 1. A lot of times if you read it with those pauses in the sentence, it helps. 9, the product of 9 and the sum of 6 and x is 1. And again, we are not solving that today. Alright, the other thing that I would like for us to do is to solve some mental math equations. Kind of like what we did on DMR for the last 2 weeks, and you were all like, oh, this is so easy. Kind of like that, okay? Some mental math. Mental math. So that means mental math means no work to show. Yay! They're not all going to be easy, though. 7 minus 3 is 10. 13 minus 10. 18 plus D equals 24. D equals 6. How about a little bit harder now? 2 minus x equals negative 5. Ooh. Negative 7 or 7? If we put a negative 7 in here, minus a negative 7 would make it plus 7, right? So just 7, right? X equals 7. 2 minus 7 is negative 5. That was a tough one. How about X over 7 equals 5. 35 divided by 7 equals 5. Good. How about what does y equal? 3. 7 minus what is 4? 7 minus what number is 4? I was looking for the solution, not for trues or falses. The last thing that I want to talk about is how you would use a table to help you guess and check. Again, the last thing that I want to talk about is how you could use a table to help you guess and check. I am not saying that you have to use this way all the time. Again, today we are not solving it the traditional way. We're going to plug in numbers for n to try to find n could be what in order for this to work. So if we said 5 times 5 plus 8 is 48. Does that work? 25 plus 8? No. I could say 5 times 6 plus 8 is 48. Does that work? No, that's 38. I could say 5 times 7 plus 8 is 48. 35 plus 8? No. I could say 5 times 8 plus 8 is 48. And that one works. So this is an example, once again, of using a table to guess and check. Putting numbers in there to try to find the solution. The solution of this would be that n equals 8. All right.